Hello. You can hear me okay? Hey guys, let's give a second for the guys to come on, and I'll start once everybody's on. All right, I think that's enough time for everybody to try to get in. I want to do a quick, maybe half hour, 45 minutes. Not really gonna go too deep into it today because I wanted to kind of spend some time on the design itself, but just want to kind of update you guys on what's been happening so far, and like how far we got. So usually I just dive right into to Fusion, but today I kind of want to kind of go over a few things I saw that was pretty interesting. Um, First was I think the Indiegogo for the monoprice delta. I think it was up today, so can't seem to find it. Uh, so basically, the delta today, um, I was pretty interested in it. I'm not sure if I actually want to get in on it because it's I don't know if you know. Okay, 455. So I still have some time, but the this Delta is on for mono price for 159 with free shipping, and I'm really tempted because just for the like the fact that I could probably use it to demo some of the prints, and then if it doesn't work out, can we scrap it for parts for $159 with free shipping is really good deal. But I don't know if I need another printer in my life, so um, I know that they say it's 12 by 120 by 120 millimeter print volume, but you don't get nearly that because it's circular. So um, I would think you probably get like probably closer to like a 10 by 10 if you're lucky. So um, but at $159, I'm not really gonna complain too much about it. So I'm still kind of on the fence about whether I want to back it or not. Mainly because Monoprice, I mean, is a big company, and they can afford to just put it up on the website to be bought. I'm not sure why they're using the crowdfunding for this purpose. So it's kind of weird. But it is a pretty portable looking unit. I mean, it has got handle and everything. So I'm debating it, but right now, um, yeah, like I said, I'm not sure if I need another print in my life. Um, is printing black and gray over there. Haribo pots, the last of the pots. I got a bag full of pots here ready to be shipped out. Um, got two orders basically for the pots and tindy, so that's helping to pay for some of the extrusion pots I would need to pick up for the Haribo Cube. Um, yeah, so that was something that's kind of been bugging me today, whether or not to back this printer or not. Um, so anyway, let's kind of move on. One of the things I've been researching the last few days was belt tensioning on the Haribo Cube. Basically, with the OT Maker, move the mechanics. One of the biggest issue is that it's pretty tough to tension the belt. So people have come up with all these crazy ideas like this one here is basically just a simple curve. So basically, it takes a little bit of the slack away from the belt. This is basically just using like a Lego piece with the three pegs to take out again take out some of the slack. A lot of the issue with these ones is that like they're not adjustable. So what it means that like you basically slap it on and take some of the slack off of it, but it's not like you can't really fine tune it. Then later on, people started coming up with things like this, which is um, two two halves. So I can take a picture of this. Two halves that hold the belt, and with the M3 bolt to allow you to finally adjust the tension between the two pieces. One of the things I don't like about this is that it's fairly small. I mean, that's a GT2 belt, and um, there's not a lot of alignment of the belt. So the you sort of lose the straightness of the belt by using this method, but it does work. I tried it; it does work. I was thinking that there's got to be a better solution to this. So, um, like the let me try to see if I can find it. Like these guys, basically, this is a coupler that fits inside the stock Ultimaker piece. This shows some of the problems with the stock XY carriage on the Ultimaker. One is the fact that the belt is actually not secure inside the like secured well inside the halves, because the halves are actually molded plastic. It's kind of hollow, so the belt just sort of loops around inside and is held on by the tension of the outside wall. So these guys basically make these inserts to have a little bit of more bite to the belt. The other thing is that you could tell that the rod holder for the cross rod is open. So basically, it's just held on by very little tension there. So those two things are being addressed with the new XY carriages I'm going to show you in a second. Um, yeah, so this has been bugging me for a few days to try to get a good belt tensioning system going. Um, I sort of went with the idea, sort of with something like this. I don't know if I can have, they have a good uh, view of this. So basically, what happens is um, there's a little carriage that fits inside, or a little belt holder that fits inside this hole, and a screw that goes through it will pull on the nut that's on this side to tension the belt. So that is a better idea than the single floating rod that we saw before. So this is the idea where I went with, but um, of course now I'm gonna be all over the place here. These ones are really meant for use on the belt, so they're not part of the carriage. They're really meant for on the carriage, and then they still have the problem with the notch on the bottom for where the rod goes. So I didn't really like that, so I kind of went and changed the rod mounting position. So let's go into Fusion for a second, and I'll show you guys what I've done. Um, I think if I bring this block, it'll show a little bit better. Um, okay, so what I got is this is the XY carriage block, and has an integrated um, block for the belt tensioning. So if I rotate this correctly and remove the top, the belt will ride through here on from one edge, and then the other edge, when after it loops around all the pulleys, comes around and is inserted to this block. This block um, will it's gonna slide back and forth inside this cavity, being tensioned by this bolt through. Take this away. Take this away. So you can see that it's being tensioned through. There's gonna be a square nut here, and this allows the adjustment of the tension of the belt. Um, with the cover in the way, you can see that it is pretty much trapped inside this cavity with this bolt going through it. So there's no chance for misalignment of the belt. As it's being tensioned, it'll be drawn into the cavity as it's being tensioned. So you could adjust the tension when the machine is all put together without having too much trouble. And this M3 bolt is actually not in the way of the belt itself. So if you go back to the other this one here, you can see that in the exploded view here that the belt will ride through here up around the pulley, up around the pulley, and through clear the top of this box and go around to the other end of the printer and comes around and into this sliding block here. And then this sliding block, like I said, the tension will be adjusted by this M3 screw here. There's about 2 millimeter of adjustment, so roughly that's about, like you can tell that that's about 1 tooth of adjustment. So we could play around with that. I mean, most of the time you're probably gonna could get away with 1 tooth of adjustment. If we need more, I could just lop another tooth off of this block, and then it'll give you 4 mil of adjustment. But right now, 2 millimeter of adjustment should be more than enough for most of the tensioning issues that we're gonna run into. The other change since last time was the use of M3 bolts in all four corners instead of and nut traps, M3 nut traps, instead of the two main M4 bolts that was in the middle. I felt that the M4 bolt in the middle, number one, didn't leave enough room here for me to do the sliding block and the belt routing. The other one was that I think the four M3 bolts would give me a more secure hold of this block. You kind of don't want this block to separate or to kind of twist, so the 4 bolts in the corner should work a little bit better. So that's what I'm going with, is 4 bolts in the corner. The other change, after I put the cover back on, is the use of a take the cover off. The use of a flange bushing here instead of a pivoting, instead of a pivoting ball, is using a rigid flange bushing here. The reason why I did that was after some thought, if you had the XY carriage block on the other side, you really don't want this reference to twist, because then you might end up with uneven movement of the block. So ended up having to go with the this is the rod without the cover. You can see that the back half of the block acts as a stop for the rod. The rod is being held rigidly by this flange bushing against the cover. So there's no chance that there's no chance that it will twist inside this XY carriage, and it keeps it perpendicular to the face of this XY carriage. So that should work a little bit better. And these are fairly cheap to replace. I think it's like $2 or something like that. So it was more economical as well. I finally figured out the 10 mil rod placement. So if I was to go to the front view, you could see that the belt, as it rides through the pulley in the back here, will just clear the top of the XY carriage. and that's how the belt routing is going to be, is basically through the top of this block across to the other pulley and coming into this slot for the belt. So um, same thing on this side. It's going to be reversed, where we clear the bottom of this XY carriage, comes around and enters the slot for this side, and then the tension is on this side. So the tensioner will always be facing outward, so that you could adjust the tension um, as when you get to the end of when you push the XY carriages to one side of the limit, you could use the adjusted tension on the belt. Um, so those are the major things. I think these blocks are pretty much on the last revision. They look pretty good. So the next test is going to be to print these out and test the idea of this belt tensioner there. And the fitment of these bushings from IGUS. So I'm gonna order the IGUS bushings and then print out these blocks to see the fitment and the operation of this belt tensioner here. And once those are confirmed, then these two XY blocks is pretty much done for now, unless we run into issues. Um, then the next thing on the list is going to be the spider. So um, right now this is not really aligned because I have to adjust the size of this middle block here. But I think I mentioned this on the last stream. Is that's what the spider is going to use this pivoting pillar blocks to compensate for any skewness in the X in the crosswise, so it doesn't bind. Um, they I would need to align these so that they and then draw out the traps like how I did for the XY blocks. I just wanted to kind of make sure that the um, the spacing of the rod is correct before I started to spend too much time on this, and also the actual footprint of the spider. So um, these two faces here, the actual footprint of the spider may need to be bigger because right now, I mean, it's minimal, just to show you how it's going to look like. But I need to kind of figure out which corner is going to grow in order to have the modular hot end system mounting system on here. Um, I'm thinking is probably going to be this corner here um, because is gonna like I'm thinking if this is the back left of the printer, then I want the extruder on the front right of the spider, which is the common placement for it. Our other choice is that we can actually put it in the middle of this face here, so that it's in the center line of the spider, but um, biased towards the front. That's the other option. The problem with that option is that is hard to route the filament input for the hot end. Um, but we could figure that out a little later. But at least maybe the mounting of it. So we might have the mounting system is going to use this face, but it offsets the hot end to one side so that it would be compatible with all any of the options that we're going to use. So that one is going to be the sort of the goal for the rest of the week, is to figure out the spider and how it's going to work, um, and then mock up the rest of this drive system so that I could start seeing how big the footprint of the print is going to be. Um, let's see what I'm going to cover. I'm still on the fence about using um, these pillow blocks, mainly because they are very bulky and I still have kind of reservations about the uh, the slotted holes for the mounting. I know that they use those for adjustability, but in our case, we really don't want the adjustability. So we want it to be sort of solidly mounted so that the rod is indexed on that bushing, and with the ability to slide back and forth, I have to do more work to make it rigid. So I think some thought needs to be put into that as well. Is how we're gonna ensure that this rod is perpendicular to the frame, and how we're gonna mount it on there. The reason I mention that is because I sort of simplistically modeled this out. I mean, this is the pulley that is going to drive this carriage, but the problem is that how do I drive this pulley? I have to somehow inside this space here also mount um, some sort of mounting system for the motor so that it would turn this rod. Um, the default Ultimaker solution is that because they use an 8 mil rod here, is to use a what are these guys? I'll show you. It's a GT2 double pulley. So one of them will be driving the other axle, and the stepper drives this one. So basically, it's one unit, and you would use that uh, in let's say this corner, and then you would have an extra pulley here where you run the stepper off of it, and then this other pulley will run the belt to the other axle. Unfortunately, I can't get one of these with a 10 mil bore. This is a 8 mil bore, so I need a 10 millimeter ID like inside bore. They don't make it, so um, at least I couldn't find it. If you guys seen a 10 mil double pulley like this, let me know. But I don't think I've seen one. And one of the things I could do is, if I really needed to, is to model this and have it printed. Um, is sort of tough to get this made, and um, I don't know if I want to print it. So it's one of those situations where a more creative solution needs to be come up with. I think the one of the things that I've been noticing is that um, yeah, printing is an option, but I one of my the way I think, right, the way I think, like, I mean, let me kind of finish the other thought. What I noticed is that a lot of people look at Ultimaker and they try to clone it, meaning like, they actually don't really try to analyze what could be done better. They basically just look at it and say, how can I duplicate or replicate some of uh, the mechanisms and some of the layout of the print itself, and then they sort of just inherit all the different decisions made at the time when we gotta remember Ultimaker's been around for a while, so the availability of the parts back when they started was low, so they really didn't have a lot of options. So they had to make sort of compromises, and I'm hoping that right now I don't have to make any compromise. I can I have a clean slate, like greenfield, as we call it in development. I have total creative freedom, so I'm hoping that I could sort of do away with some of the limitations. One of which is the use of like non-standard parts like the double pulley, because like the double pulley for 10 mil bore is not a standard thing, so it's gonna be tough to find. And even if I find it, um, I thought it was kind of inefficient to have two belts, one belt driving the axle and one belt driving the other axle. So I'm trying to see if I could creatively run a single belt to drive both characters and run it off of the stepper. That is going to require some layout kind of textures here to figure out how I do that. And remember too is that I sort of had um, restricted myself not to use certain extrusion grooves because I had to save those or reserve those for the panels. The other one is that I'm trying to see if I could place the steppers outside, or at least not within the envelope of the not within the envelope of the heat chamber or the enclosure, because I guess I want to kind of make sure that the steppers have enough cooling. So um, that in itself is creating a little bit of a problem. It's kind of sort of like working with all these different restrictions and rules. What is the purpose of the smooth center section? You just use a long single pulley. Um, this section here is the mounting for the pulley. So um, I have one here. So this is what no, focus. There we go. So that's where the set screws go. So normally what they do with the double pulley is they duplicate the smooth section and then attach a pulley on the other side. Well, not attach, but they'll machine another pulley on the side. One of the things that I sort of want to get away with, I mean, I did approach a few people that could CNC the double pulley, is I want to kind of stick with off the shelf stuff that is people will get, and if I had to go and get a part machine, it really doesn't make any sense because I mean then not only I'm gonna have the part, and if I ever go away, then you guys can't make them anymore. So if I could kind of do it with standardized parts, I would do it with standardized parts. Um, I explained that double pulley situation. So one of the things that I do as a software developer at work is sometimes we run into business requirements, business problems that seem to be hard to solve or unsolvable. So one of the skills that we picked up is the analysis of the situation and see if we actually need to solve the problem. I mean, if we can eliminate the problem without solving it, then obviously it's just the best course of action. So in this case, um, I'm trying to see uh, if I could eliminate the drivetrain loss of the double belt and the need for the double pulley by running the running a sort of a L bracket system. So what I mean by that is, um, let's see if I can make some of this stuff go away. Uh, yeah, there we go. That will work. So let me make some room here. So I want this rod to spin this pulley that pulls this XY carriage up and down this rod. So one way to do that, like we've been mentioning, is have a double pulley here that will allow me to run a second belt to a stepper that might be somewhere in space here. So one thing I could do is um, I could mount a. Maybe I could just insert it so you guys can see what I'm talking about. Um, there you go. Insert this into current design. Okay, I'm not gonna get perfect alignment on it, but um, yeah, there you go. That works a little bit better. So what I'm thinking of doing is however I mount this stepper, I would run the belt straight down um, onto this pulley here, um, into this XY carriage, right? And if this XY carriage goes all the way around to the other pulley, comes back, and right before it goes into this pulley, I have some kind of bearing here that will bring it up and around, bring it up and around the driver. So that gives me like a L-shaped belt configuration, then I could drive. Then this could drive this and move this at the same time. But that's going to require me to somehow mount this stepper in a way that it forms an L, and then also have that mount have enough space for a pulley here for the belt as it comes across to make its way up around the drive face. Um, so that is doable, but then I also have to do the same thing on the bottom here for the other drive. So um, that's going to be interesting. Is how do I make this mount work to run that belt in such a configuration, and the placement of this motor so that it's outside the enclosure but yet able to drive this belt. Um, I'm hoping is that the shaft of the stepper is going to be long enough so that at least this one I could use the outside face of the extrusion to mount the motor, and the idler. I guess it's the idler. They call it. I think they call it the idler on the belt to bring it around to the top of this. That way, is that I have a single belt that will run everything, and I have minimal drivetrain loss on the axle here. So hopefully that will work. Hopefully, and yeah. So let's see what happens. I mean, I'm gonna go and so I guess like I said, the first thing is gonna work on the spider, and then next thing is work on this motor mount. And once those two are done, um, we're pretty much ready to go for the movement test, right? Because I don't have to worry about how the whole spider mounting is going to work yet. What I really care about is, does this drive system move this spider, or move these move these two XY carriages in a way that this spider will um, work the way we anticipate it and move within this XY coordinate system without binding and in an efficient manner. And if that does, then what's the nice thing about that is that then it proves out the theory of the mechanism itself, or the mechanics, and then we could split the project to two different forks. One is getting the controller and the motors and everything working together. Um, that because now the mechanics is for the XY is pretty much set. We kind of know it's gonna work. The next thing is gonna be, like I said, is one fork of the project to go on and do the electronics and the smooth way configuration, get and start to kind of flush out the configuration for the movement itself. Then the other fork is going to be within this XY coordinate space and these rod spacing. How do I fit the Z the Z platform, and how does that mount to the frame itself? Once those two sort of forks diverge and work on it in parallel, then at the end of those two forks, um, we'll bring it together and start to uh, put it into a 3D space. Then basically wrap the extrusion around that whole mechanism. So it's sort of backwards in a way. I mean, a lot of people do it where they build the frame and then they model the parts to fit within this frame. But we are saying take the mechanism and the XY movement and Z movement, make sure that we are doing our best we can with that mechanism, then build the frame around it. So um, it's weird, but it works. So I'm hoping that it also allows us to have diverging paths that eventually converge into a design. So um, I anticipate that I'm not going to be able to do everything myself anyways. That's why I'm kind of setting up the project to have like branches and forks so that we don't have to rely on the one single design. Um, I think like the it's a good plan. So if you guys have any suggestions, ideas, or feedback on what you guys seen so far, yeah, we're welcome to hear it. I'm really happy about how this tensioning mechanism came out. So, like I said, the fact that I don't need a separate tensioning block makes me happy. So I'm hoping that works for you guys as well. Um, and with the feedback you guys gave on the last Haribo design, I am making sure that all the different hardware fits within where it needs to, so that, and also this allows me to do a count of, like, quickly come up with a bomb for the parts we need. So uh, hopefully we won't run into the same situation as we ran the last time, where we buy extra hardware we don't need, but is that's gonna be minimalized. But I think we're still gonna have issues. But at least we have um, we have a good starting base. Um, let's see. Um, okay, how thick is the part at the bottom of the belt slot? It looks awfully thin. This part here, or this? You talk about this distance here. Yeah, 0.9. We could play with that. I mean, is the idea is there? It's so I'm not sure if this is the correct way to do it. In Fusion 360, I sort of didn't want to have um, two different models. Meaning, I didn't want to cut out this whole section only to draw it again in another model. So I sort of let's see if we can get you know, move this back down here. So there we go. I sort of cheated. I sliced this block out of this cavity by making really really small cuts. So basically, this block is floating in midair right now, just so that I could kind of line up this boat and everything. So if if this needs to be thicker on the bottom here, all I have to do is basically make these two cuts deeper, and then bring it down maybe another millimeter. I think another millimeter would make this a lot stronger. I agree. So I will do that. Bring this down another millimeter, so that this slot for the belt is a little bit deeper, and it won't change the placement of the bolt. So we should be fine. Because one thing is, I didn't want to change the depth of this nut trap. So I will lengthen this, but keep the bolt in the same spot. I think that works. Thanks for the feedback on that. Um, what else is there? The I'm starting to really like these pivoting bushings. So I'm gonna try to get some in next week and see if I can actually use those on the Haribo slash MK2 for, like, let's say the bed and the other, like the Y axes and the X axes and so on, because it's a pretty simple fix, right? We just basically make a holder for it and then have it bolt to the bottom of the carriage, and then we will do away with all the issues we've been having with binding, because the longer uh, linear bushings, with this is slightly off, you're gonna get binding. So these will totally do away with those. I'm gonna try to see if I get some in and do some testing and see if that works. If that works, then we're golden, right? What else? I guess that's pretty much it for the update on the Haribo Cube. Um, let me just minimize this and bring up the this one. So the internet's kind of slow today for me. I don't know why. I've been bugging Filaments SCA just so I guess while I'm waiting for this thing to load about the PTG being always out of stock. Um, I've been trying to get them to restock for a while now, and they said this week, and it's already Wednesday, so I'm hoping that they restock soon because I'm running out of the red. I ran out of the red PTG. I need those for to finish the 2XNs that I promised one of the customers, and yeah, that's bugging me. So I gotta go bug them tomorrow. So again, like we were gonna go through this before, and just sort of quick show you guys. Again, I don't know why they do this. Is basically they are using printer blocks instead of again going through the through hole, and um, yeah, unfortunately, I don't know why they do that, and it's kind of bugging me. And I hope that like I hope the idea of using correct structural pieces or structural alterations to get the strength is something that could catch on. I mean, a lot of people don't do it, and they start wondering why, like they run into like vibration issues and all that because you don't have a sturdy frame, right? So that's going to be the biggest problem, and like even this one that's claiming to be like an Ultimaker clone still uses those corner brackets instead of kind of a rigid mounting system. So one of the things that I wanted to point out in here was the next slide is they use a kind of a cantilever system, right? So there's two 12 mil rods that hold up a platform. The platform extends out and the bed sits on it. So I don't know if it shows a side view. Yeah, so you can see that is actually just a cantilever with the two 12 mil rods. So the one change that we are doing is we're going. I was going to go with two 12 like two on each side, but I'm starting to think that might be overkill. One of the other sort of clones use one 12 mil rod on either side, and that seems to work okay. So I don't know. I don't know. I mean, save that's only saving us like $12 plus the two brackets, so might not be worth the $20 to save on each side. $40, maybe we just go with two 12 mil rods. I'm not sure. I think that's why I said we have to work out the Z mechanics, right? So okay, yeah. So I'm not gonna linger anymore. I mean, I gave you guys the 45-minute update on what's happening so far. Um, it's sort of interesting because like a lot of the things like let me just bring this back up again. Um, like a lot of the interesting things like the the relationship between the pulley and the XY, the spider and on the two XY characters and the belt placement. A lot of those in the beginning when I started to sort of reverse engineer slash replicate some of the ideas. It was totally off. I mean, if you guys watch the previous streams, you see that I had these two rods in like opposite ends of the world, and then the spider was upside down. It wasn't correct orientation. There was no way that these pulley would have driven each other. And then as time goes on, we sort of converge onto the working branch, and I started to also look at things like you know, making these bigger, like wider, and integrating the tension and stuff like that. That um, seems to be the way I'm sort of like replicating a lot of the probably like the roadblocks and the limitations of the system, and as I'm trying to learn as much as I can on it, and is it's sort of like walking down a path of like trying out different things and then eliminating all the ones that don't work. And I think it's like something that maybe Ultimate guys did when they first started is to try to sort out like the working mechanics and then what works and what doesn't. And I'm kind of going through it at a sort of bookneck pace. I mean, I went from nothing to work like something that is semi-working in my mind in like 2 weeks. I mean, I've been working nonstop for 2 weeks now, so hopefully it will come to something next week. Like it'll come to fruition next week with the first movement test or something. I'm gonna start ordering all the parts starting tomorrow, and hopefully by next week, at least I have some of the first articles to test on the off the printer. The prints are coming off the bed soon, so they should free up the printers and I can start printing these test parts. Um, yeah, so still gonna keep this close source for now. I mean, I think we all saw what happened with Scott and his latest sort of um, hijacking. So um, not gonna put it on GitHub until we kind of sort out the licensing and all the other stuff that's gonna come to this because it is all net new work that I'm drawing all these things on like from scratch. So it's not like a derivative. So I'm hoping to sort of keep it close into if I can work out how I want to what terms I want to put on the source files. Anyway, I'm gonna go and have coffee with the guys now and pick up and drop off some stuff. So I think next stream would be Saturday. Saturday at noon is gonna be next stream. So that gives me Thursday, Friday, and Saturday morning to sort of work out the rest of this stuff. And once I get it to a good state where like the pulleys and everything is in the right place and I got the motor mounts working, I'll mock it up again and how I did it before and have it sort of animated so you can see the movement of the different parts. I think that helps to visualize how it's gonna work and give it's a little bit more exciting than looking at a partially assembled corner. Then we can start looking at once I lay out the bed onto here, we can start looking at how big we need to make the printer and whether or not there's any way to save some space off the design. But so far, I think we optimally use the space. I mean, it's every square inches or square millimeters used in the whole printer. So it'd be tough to find savings there, but we could work that out. I'll see you guys on Saturday.